This is the 2016 Year 7 NAPLAN non-calculator paper. This table shows the length and width of 4 rectangles in centimetres. And it's asking which rectangle has a perimeter of 32 centimetres. So remember, when you are looking at a rectangle, that you've got your length and width, but you have to add them twice. Our length and width, but to find the perimeter you need to do length plus width plus length plus width. So just looking at each of those, so if we want a perimeter of 32, a quick way would just be to find the one with a with length and width adding up to 16. So if you look at rectangle A, perimeter is again 10 plus 6, length plus width plus 10 plus 6. So 10 plus 6 is 16 plus another 16 is 32. And your answer is the first rectangle because it has a perimeter of 32. Okay, if you look at, say, rectangle D, it's got a perimeter, sorry, a little typo there, that's a perimeter of 64. So 20 plus 12 is 32, but you have to add your 20 and 12 again. And all the other perimeters, they do not equal 32. So your answer there is rectangle A. Now for question 27. Now this is non-calculator, remember. So the regular price of a shirt is $24.50. And the shirt is on sale for 10% off that regular price. And what is the sale price of the shirt? So you have to work out what the discount, there will be a discount. So all the money off will be 10% of $24.50. Now to find 10% of something, it's like 50% is a half. So if you want to find 50% of something, you halve it. So you would divide it by 2. If you want to find 25% of something, now 25% is a quarter. So if you want to find 25%, you divide by 4. But for 10%, if you want to find 10% of something, you divide by 10. So we've got $24.50 divided by 10. Now to divide by 10, you're making it 10 times smaller. So we move the decimal place back 1 place. So $24.50 divided by 10 is $2.45. So that will be the discount off the shirt. So you don't pay $24.50. You will pay $24.50 take away $2.45, which is $22.05. Okay, so that is the sale price of the shirt, $22.05. Paul is playing a guess my number game, and he gives clues about his number. Now his number is a square number, and so let's just first look at the square numbers. So his number is a square number. So the square numbers, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81. And we know that 10 squared is 100. However, it says down here that the number only has 2 digits, so we don't need to include 100. Now, it also says my number is divisible by 2 and 9. So let's just look at divisible by 2 would be the even numbers of those numbers up there. So the ones that are divisible by 2 would be 4. Okay, that's divisible by 2. So is 16 and 36 and 64. So they're all the divisible by 2 numbers. Now divisible by 9. 9, we need to see which of these numbers that 9 goes into. Now 9 doesn't go into 4 or 16, but we know that 9, it doesn't go into 64 either, but 9 goes into 36. So 9 times 4 is 36. So divisible by 2 and 9 would be the number 36. Okay, so therefore our number is 36, which is shown there. Question 29. Pears cost $4 per kilogram and Ben buys $4.15 kilograms of pears, and how much does he pay? So the cost of the pears will be 4.15 times $4. Now, look, some of you may be able to just look at that and say, well, 4 times $4 is $16.15 times 0.15. Or you can look at it as You can look at it as 0.15 times 4. So it's 0.15 plus 0.15 plus 0.15 plus 0.15. Now 0.15 and 0.15 is 0.30, and doubling that again you get 0.6. So like I said, the other way you can look at it this is as follows. We can just do, because we're trying to do 4.15 times 4. Okay, so 4 times 4, looking at the whole number parts, is 16, and 0.15 times 4, like I said, 0.15 times 4, you can do 15 times 4, which is 60, and know that you've got 2 digits after the decimal point, or you could do it like this: 0.15 plus 0.15 plus 0.15 plus 0.15. Now that's like 15 and 15, it's 30, so that's 0.3, and another 0.3 is 0.6. And I'll just put 0.60 because we're talking about money. Okay, so that's another way you can do 0.15 times 4. So therefore the cost of the pairs is $16.60. Look, the other way you can do this is using the algorithm, multiplication algorithm. You would multiply 415 times 4. Now 5 times 4 is 20. We put the 0 there and we carry the 2. And 4 times 1 is 4, plus 2 is 6. So just moving that over. And then 4 times 4 is 16. So we put in the 16 here. I'll just move it all back. So we've got 1660, but we have to determine where the decimal point is. So this is roughly 4 times 4, which is approximately 16. So the decimal point would go after the 6 here, so it would be 16.6. The other way you can look at it is we're multiplying 415 times 4, or 4.15 times 4. There are 2 digits after the decimal point here, the 15, so there must be 2 digits after the decimal point here. So I would put the decimal point there. Okay. Lucy enlarged her rectangular deck so that the length and width were both tripled. So I've drawn a small rectangular deck there and one a bit bigger. It doesn't have to be exactly 3 times bigger, okay? And the question is, how many times as large as the area of the original deck is the area of the new deck? So we need to, let's just make up some values for dimensions for the original deck. Let's say it's 1 meter by 2 meters, just some nice easy numbers. So therefore the area, remember, is length times breadth. The area of this original deck would be 1 times 2, 1 meter times 2 meters, which is 2 meters squared. Now it says that the length and width of the original deck are tripled. So 1 times 3 is 3, and 2 times 3 is 6. So the new deck has dimensions 3 times 6. So the area of the new deck would be 3 times 6, which is 18 meters squared. Okay, so just making a bit more room here. And so we need to see how many times larger the new deck is. So to see how many times larger it is, you have to see how many 2's go into 18. So we do 18 divided by 2, number of times larger is 18 divided by 2, which is 9 times larger. Okay, and that's shaded in there. So just remembering not to subtract there, but to divide, because, for example, if we say it's twice as large, 2 times 2 would be 4, or if it's 5 times larger, the area would be 2 times 5 is 10, like this would have been 10. So you must use, if you've got 2 areas there and you want to see how many times bigger this one is than that, you just see how many these small areas go into the large area. So we would use division. Okay, question 31, it says this year Sam's age is both a prime number and a factor of 57. And then it says in 2 years' time, Sam's age will be a prime number again. What is Sam's age this year? Now, we could list all the prime numbers, but that would take a long time. I think it's easier to list the factors of 57. Now, the factors of 57 are 1 and 57. They're a pair. Now, we know that 2 is not a factor of 57 because 57 is not even. So if 2 is not a factor, neither will 4 or 6 or 8. They won't be factors. 3, well, 3 is a factor because if we add up 5 plus 7, we get 12, and 12 is divisible by 3. Also, we know that 60 is divisible by 3, and 57 is 3 less than 57 is 3 less than 60, so 3 will go into 57. Now, because we know that 3 times 20 is 60, 20 or 20 times 3 is 60, then 3 times 19 will be 57, because 60 take away 3 is 57. So 3's partner is 19. Saying that 3 times 19 is 57. Now, because 2 is not a factor of 57, 4 will not be a factor. 5 is not a factor because 57 doesn't end in a 5 or 0. 6 will not be a factor because it's 2 is not a factor as well. 7, well, we know that 7 8s are 56, so 7's not a factor. 8 is not a factor. 9 is not a factor because 9 6s are 54. 10 is obviously not a factor. Neither is 11, or 12 is not. 13 will not be, neither will 14 or 15, 16's even does not go in, etc. So there are no more factors there of 57. So it says this year Sam's age is both a prime number and a factor of 57. Now, which of these are prime numbers? Well, 3 is prime and 19 is also prime. We know that 57 is not prime, okay? So the prime numbers are, from those above, are 3 and 19. So therefore, Sam is either 3 or 19. Now, it says, so, okay, so of those numbers, the prime and the factor of 57 is the numbers that are both prime and factors of 57 are 3 and 19. 2 years' time, Sam's age will be prime again. So if we add 2 onto each of these ages, 3 plus 2 is 5 and 19 plus 2 is 21. So having a look at that. So in 2 years' time, Sam could be 5, which is 3 plus 2, or Sam could be 21, which is 19 plus 2. Now we know that 21 is not prime because 7 times 3 is 21. So therefore, 5 is a prime number, 21 is not prime, and so therefore Sam is, so 5 is the correct number here. But what is Sam's age this year? So therefore Sam is 3 years of age this year. Okay? And now for this last question. It says this object is made by cutting off each corner of a cube as shown. How many edges does it have? Now if we look at the top of this shape, we have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 edges on the top face. We have 8 edges on the top, as we counted before, and if we consider the bottom as well, there will be 8 edges on the bottom. So we've got 8 plus 8 is 16. Now we're going to look at the front faces. Now remember, this edge here has been counted, and this edge down here is being counted from the bottom. So I'm just going to mark those in. Oh, actually, I don't need to, but just remember that this edge here is already counted from the top face, so is this one. So if we look at this front face, we've got 1, 2, 3, 4, 5, 6. So this front face and the back face will have 6 edges that have not been counted. So edges on the front and the back, not hexagons actually, they're octagons. So I'll just fix. As I said, we've got 1, 2, 3, 4, 5, 6. We don't count this one here and we don't count that one there. So that is the front octagon. We've got 6 edges here that haven't been counted and 6 at the back, so that's another 12. We're now going to look at these side faces. Now I know that the top here has been counted and this side just there has been counted, the bottom there and that other side there will have been counted because it touches the back face. So therefore we've just got 1, 2, 3, 4. Now if I pretend this is the side one, the only ones that I haven't counted are 1, 2, 3, 4. So that's over here, 1, 2, 3, 4. So on the 2 side faces, this one that I'm circling over here and this other one that you can't see, we have another 4 edges. So 4 times 2, remember they're octagons, okay? 4 times 2 is another 8. So now I think we've added everything up now. So let's add those all up together. So the total edges is 16 on the top, We've got 12 extras at the front and the back, and on the sides we have 8 extras. So therefore the total edges is 16 plus 12 plus 8 is 36. And if you're adding this up without a calculator, 12 plus 8 is 20, plus 16 is 36. So this object has 36 edges. Okay, that's the end of this video for the 2016 NAPLAN non-calc paper.